Good morning, everybody. Hello, my beloved students. Hello again. We have returned again to Geometry Similarity Part 2. Okay, we go now to first slide. Yes, with me. We have here two shapes. Yes, two shapes are similar only when what? When each two corresponding sides are in proportion and each two corresponding angles are equal. All regular polygons have the same number of sides are similar. What is a regular polygon? We call the polygon will be regular if all sides are equal in length and all angles are equal in measure. Like what? Like squares. We have here small square, middle size square, and big square. All of them are similar. Why they are similar? Because they are regular squares or regular polygons. And we have here, what is the shape? We count 1, 2, 3, 4, 5, 6. So it's hexagon. It is a regular hexagon here, the small one, the middle one, and the big one. All of them are similar. Why they are similar? Because they are regular. All angles are equal in measure and all sides are equal in length. Okay, let's go to the second slide here. We continue conditions of similarity, and remember, my dear students, that all corresponding sides are proportional and all corresponding angles are equal in measure. If we have rectangles, like here, we have here three rectangles. Rectangles doesn't considered as regular polygons because they have equal measures in angles. All angles are right angles, but they have not equal in sides. So all rectangles are not similar to one another since only condition 2 is true. It's not enough. It's necessary, but it's not enough because all angles are equal in measure because they are right, but we have to satisfy these corresponding sides are in proportional. Okay, let's go to the first second slide. We have here two rectangles, rectangle A and rectangle B. And we have this side equal 8 centimeter and this side equal 12 centimeter. We have here 5 centimeter and this width equals 7.5 centimeter. We will go to scale factor K. Scale factor K equals 12 over 8 or equals 7.5 over 5 because 8 is corresponding to 12 and 5 is corresponding to 7.5. So 12 over 8 equals 3 over 2 or 7.5 over 5 equal 3 over 2 only. So 3 over 2 here equals 3 over 2 here. So the same ratio. So we can say that the two rectangles here are similar. And from A to B, from A, this is rectangle A, to rectangle B, it would be 3 over 2 greater than 1. So it is an enlargement. But from B to A, it would be 2 over 3, which is smaller than 1. It is shrinking. Okay? And when the scale factor, which is called K, equals 1, then the two polygons are congruent. Will be A as B exactly. Length will be the same and width the same if K equals 1. Let's go to the next slide. Example connected with the hobby applications. We have here two cars. This car is a racing car. It's a big car. Its length equals 5 meters and its width equals 1.8 meter. And we have a model here for this car. It's exactly similar to it. So its width equals 6.3 but centimeters and x meters. And because of similarity, we will try to find the value of x. Okay? Find the length of the model to the nearest tenth of a centimeter. Let x be the length of the model in centimeters. The rectangular model of the racing car is similar to the rectangular racing car, so the corresponding lengths are proportional. Let's go the next. We have the same two cars. We have the ratio, equal ratio here because of similarity. Length of racing car over length of model equals the width of racing car over width of the model. So when we put 5 here over x equals 1.8 over 6.3. We have the cross product proportional. We have 5 multiplied by 6.3 equals x multiplied by 1.8. Simplifying, okay, 5 multiplied 6.3 equals 31.5 and x multiplied 1.8 equal 1.8x. So divide the both sides by 1.8. We will get 17.5 equal x, or x equals 17.5 centimeter. So the length of the model here equals 17.5 centimeter. Let's go to the next slide. We have determining similarity. Triangles ABC here and triangle DEC are similar. Ask yourself why. Why they are similar? We have here the angle ACB is congruent to the angle ECD, or measure angle BCA equal measure angle ACD, and we have an angle B equals angle E because of alternate angles, because we have AB parallel to ED, and this angle B equals this angle E because of alternate. We have also measure angle A equal measure angle D equal because of alternate. So the two triangles are similar since ABC is similar to triangle DEC. We know that corresponding sides are in proportion, so AB goes to DE, okay, because they are corresponding, and DE goes to the CE, and AC goes to DC. The order of the lettering is important in order to show which pairs of sides correspond. We have here two triangles, and this triangle is similar to them or the same as them. We have here the triangle ADE, and we have BC parallel to DE. We have the angle BAC equal the angle DAE because they are common angle. We have the angle ABC equal the angle ADE, corresponding angles because of similarity here. We have the angle ACB equal the angle E because of corresponding angles, because BC parallel to DE, and line drawn parallel to any side of a triangle produces two triangles. One of them is the smallest, which is ABC, and the other is the greatest, which is ADE, and they are similar. Triangles are similar. Yes. Next slide. Example problem. It goes to a tree 5 meters high, casts a shadow 8 meters long. Find the height of a tree casting a shadow 28 meters long at the same time. Yes, we have two trees now. This is a tree which is height of 5 meters, and this one makes a shadow of 28, like that. We have this small tree of height 5 meters, and it makes a shadow 8 meters. And this big one, its height equal h, and makes a shadow 28 meters. At the same time, we connect the top of the tree with this point and the other one, and explain why the triangles must be similar. These two triangles, sure, they are similar, but why? Because we have here the shadow and this one at the same time, so it's proportional, and this angle is right, equals this angle, so the two triangles here are similar, so the heights are proportional. SF means scale factor. Scale factor here equal 28 over 8 here equals 3.5. So height equals scale factor multiplied by 5 here. The answer will be 17.5 meter. So the height of this big tree now is 17.5 meters. We have here example problem. The two triangles here below are similar. Find distance y. We have the triangle AEB, and the other triangle, which is big, is ADC, and we have here AE equal 5 meters, ED equal 45 meters, and CD equal 20 meters, and we would to find the length of y. Scale factor here equals 50. Why 50? Because AE is proportional to the whole side AD. So AD equal 50 because it's equal the sum of 5 and 45 here. So the sum equal 50 over 5 equals 10. When we multiply or divide 20 here divided by 10 equals 2 meters. We have here two triangles also, the triangle ABE and the other one ACD. This is the model of this triangle. We have here, we would like to calculate the length of CD and calculate the perimeter of the trapezium EBCD. Scale factor here equals 9 over 6 equals 1.5 centimeters. And to find CD, just multiply 1.5, which is the scale factor, by 4.8. The answer will be 7.2 meters. So CD here equals 7.2 meters. And to find EC, multiply the scale factor, which is 1.5 times 4.2 equals 6.3 meters. So here AC equals 6.3 meters. We have here BC. BC, where is it? We have here BC equals 6.3, which is the total side AC, minus 4.2, which is AB. So the answer of BC equals 2 meters. To find the perimeter of the trapezium EBCD, we have to find the length, sum of the lengths of the sides. So we have 7.2 plus 3 plus 4.8 plus 2.1. So the answer or the sum equal 17.1 meters. Okay, we have BEDC is the trapezium. We have to find the sum, so it will be 17.5 meters. We have here another slide. talks about the ratio of perimeters of two polygons. If two polygons are similar, then the ratio of their perimeters is equal. So the ratio of their corresponding sides. We have here two polygons, ADCB and SRQP, and if we add AB plus BC plus CD plus AD over SP plus PQ plus QR plus RC, the same ratio, this ratio will be equal any ratio of the similar sides. Okay. We have example here. A parallelogram GIHF is similar to a parallelogram LKJF. Find the value of y. We have the two parallelograms here, the big one and the small one. Yes, we have GI over LK, GI here over LK equals GK over Y. So when we substitute GI equal 24 and LK equal 15 equals JK equal 12 over Y, and make cross multiplication, 12 times 15 will be equals over 24, so Y will be equal 19.2 centimeters. Okay, my dear students, let's go now to some examples here. We have a triangle. We will talk more about right angle triangle here. And it is a right angle triangle here. And if we draw a perpendicular from the right angle, it will be A, B, C, and D. AD perpendicular to CB will mean that this angle is right also. Okay. From this triangle, it produced two triangles, and we have the big and original triangle ABC. We have here, because of this is the right angle, we have this angle equals this one, and this angle also equals this one. So we have measure angle BAD equal measure angle C, and measure angle DAC equal measure angle B. So the two small triangles here are similar. The triangle ABD is similar to triangle CAD, and all of them are similar to the original triangle, which is CBA. How can we write them? The order in writing is very important. So try to say dot, star, and write. So it's triangle CAD, triangle CD, CAD will be similar to triangle CAD here, dot star right will be similar to ABD, and triangle CAD is similar to triangle is a big one, we call it from dot star right, so it's CBA. We have here three triangles are similar. We have triangle CAD and triangle ABD BD, and triangle CBE. All of them are similar. Okay, let's draw them again. Yes, we have here the original triangle again, which is right, and we draw perpendicular from it here, A, B, C, D, and don't forget that this angle equals this one, and this star angle equals this one, and this is right also. So the triangle A, C, D similar to triangle B, A, C, D means star, dot, and right. So the similar triangle will be star, dot, and right, BAD. All of them similar to the big triangle or the original one, which is BCA. We have here AC over BA, AC over BA equals CD over AD. Okay, equals AD over BD. Try to concentrate with me, concentrate now, and try to find what is AD here. It's repeated here. So we have 2 AD. When we multiply AD by AD, it will be AD power 2. Equal what? Equal CD multiplied by BD. CD times BD. When we look here at the figure, okay, we have here, we have here AD power 2 equals CD times BD. Do you remember, my dear students, this called in primary 2 the Euclidean theorem? AD power 2 equal CD multiplied by DB. So from similarity now we try to simplify or try to prove that AD equal times AD equal AD power 2, and the answer will be CD times BD. Let's go to another thing. Yes, right angle triangle is very important, my dear students, because when we have right angle triangle and we draw from right angle a perpendicular to the base, it makes 3 similar triangles. The 2 smaller triangles are similar, and they are similar to the original. And try to prove something else. So look with me again. Here, if we have A, B, C, and we have the same right angle here to D, okay, we have triangle A, we have here, we can put the equal angles, so we can put them in the order. The triangle ABD similar to triangle CAD, similar to original triangle, which is CBA. Try to connect this triangle with the original one, we will find that if we divide AB by CB here equal BD over BA equals AD over CA. Try to find out the similar here. Okay, we have here AB repeated. We have repeat BA twice. So AB times AB will be AB power 2 equals BD times CB. Okay, when we look at the figure again, AB power 2 here equals BD multiplied by BC. It's also the Euclidean theorem or Euclidean theorem, and we proved it now from similarity. We have AB power 2 equals BD multiplied BC. Okay. Okay, let's see something again. Okay, we have here an example. Let's draw with each other. Now we have a triangle here, B, C, A. And we have, this is right angle, and we have perpendicular here, which is D. And we have the length of BC here equals 3x plus 4 centimeters. We have BD equals y minus 3, and D equals 4.5 centimeters, and CD equals 8 centimeters. So find X and Y. From similarity here, we have proved that BC power 2 equals CD multiplied by CA. So 3x plus 4 power 2 equals CD, which is 8, multiplied by CA, which is 12.5. And we have BD power 2 here equals DA multiplied by DC. DA here equals 4.5 multiplied by 8. The answer will be 81. So Y, the answer will be 36. And we have here this number y minus 3 power 2. Get the square root. So y minus 3 equals 6. So y equal 9 centimeters. Okay, don't forget that when we make square root here, we make another one here, 36. And someone asked me why we didn't put positive or negative here. We deal with length, so ignore negative here because length equals no negative. So we deal with positive only. So y minus 3 equals 6. So y equals 6 plus 3 equals 9 centimeter. Okay, let's go to the second part of the question. We have to draw it again. right angle triangle here, BCA, right angle triangle, and perpendicular to AC equals D here, and we have 3x plus 4, and we have 8 here, 4.5. So 3x plus 4 all power 2 equals 8 multiplied by 12.5, which is CA. CD here equals 8 here, and multiplied by 8 plus 4.5 equal 12. So, okay, 3x plus 4 here, power 2 equals 100. So, take the roots of the two sides. 3x plus 4 here equals 10, and solve the equation. 3x equals 10 minus 4, so 3x equals 6, and x equals 2, so we have x equals 2 and y equals 9. Let's move to another question. Yes, we have another one. Okay, we can try to write. Okay, my beloved students, we have a little break and we be back again. Don't go anywhere. My dear students, again we have similarity part 2, and try concentrate with me. We have here the school book question here. We have a rectangle, so concentrate with me. Okay. Okay, tamam. Okay, we have triangle here, A, B, C, D, and we have here the length of rectangle. If it is rectangle, so all angles here are 90 degrees or right, and we have here the width, and we have AC here, and we have DF, which is perpendicular to AC at E and intersect CB at F here. So the question is, prove that area of triangle, area of quad or triangle, rectangle ABCD equals square root AE multiplied by AC multiplied by DE multiplied by DF. Okay, to prove this question, look carefully at this triangle here. We have triangle ADC, and we have L, which is DA equals DA power 2 here equal AE multiplied by AC. We write here DA power 2 equals DE multiplied by AC. This is the equation number 1, and we have the equation number 2. We have here the DC, which is the width, and DC power 2 here equals what? Equals DE multiplied by DF. Why? Because we have right angle here and it is perpendicular here. From similarity or Pythagoras theorem. So DC power 2 here equals DE multiplied by DF. This is the equation number 1. And we have to find square root for the two sides here, to find DE only, and put square root to the two sides here also to find DC only. And we know that DA is the L, which is the length of the rectangle, and DC, it is the width of the rectangle. And we know that area of rectangle equals length multiplied by width. So area equals square root DE times AC multiplied by the other square root, which is the width, which is equal DE multiplied by DF. And we can connect these two roots into one root here, equal square root, one square root equal DE times AC times DE times DF. Okay, we have here CD power 2 equal DE multiplied A DF, and this part, which is DA, equal AE multiply EC. Okay, let's go to another question here. Now we have another question. We have two triangles here. This one and this big one. This triangle called EB, okay, D, and we have CA, okay, and we have the length of EB equals 6 centimeter here, and this is 9, this is 12 centimeters, and this is 4 centimeters, 12 centimeters here, and we have this one equal 8. Okay, we try to prove that the triangle, the two triangles are similar, this one and this one, and we haven't the two names. We try to put the sides of the first triangle from the smaller to the greater. So we put 6, 9 and 12. 6, 9 and 12 here, and we put the sides of the second triangle from the smallest to greatest. So we arrange them from 8, 12 and 16. We have BC here, the sum of CD and DB, so it's 16, and put a fraction here. What we will find, we will calculate them, and we will find that each of them equal 3/4. All of them equal 3/4. So the sides are proportional, and this case we called it S similarity, which means that side similarity, and we proved now that the two triangles are similar. And he want us to prove that the ray BD here bisects the angle B. What means that the measure angle EBD, we try to prove that equals triangle the angle ABC. We try to prove that the angle here equals the angle here, so the BD ray will bisect it. If we want to arrange or put in order the triangles, we put them from the smallest to greatest. So we have here BE equal 6 and ED equal 9 and DB equal 12. We arrange them, so we can say the triangle BED is similar to triangle here this triangle start with smaller to greater, so we call it BAC. And we try to find out these two angles, which is B. We have here, if we call the triangle EBD, concentrate with me, we start with E, goes to B in this side, and return back to D, will be equal the measure angle ABC. So measure angle EBD equal measure angle ABC, which is the two angles. We have here the two angles here are equal, so BD, the bisector of the angle B or the angle EBA. Okay, let's go to the second question here. We have a question here. Let's go to it. We have this figure like that. We have a triangle here and another one, and we have this side. We call this D, C, B, and E, A, E. And we have just the ratio. He gave me that the ratio AC over the ratio over AD equal another ratio, which is AE over BE. And we have another ratio, which is AB over AE equals CD over AC. Okay, so we have two ratios only, and the request is to prove that CD here, to prove that CD parallel to BA and DA parallel to EB. We tried to prove that this side parallel to this side and this one parallel to this one. How? I have only two ratios equal here and two ratios equal here. Try to think. When the two sides are parallel here, if we could prove that this triangle equal this angle equals this angle, and they are alternate here, then we will prove easily that BA parallel to CD. And if we try to prove that this angle equals this one and they are alternate, then we will easily prove that DA parallel to EB. So look at these two ratios here. Where is AC? AC here, and AD here on the same triangle. What will we do? And AE here over BE, the same triangle also. But we have property in the ratio we have studied in preparatory 3. We can put this ratio AC over AE equals AD over BE. If we put them like that, AC over AE here equals AD over BE. Look at them. AC over AE, AC over AE. Yes, we transferred from one triangle to another, equals AD here over BE, the other triangle. Okay? And try to make the same thing with the other ratio. Here we have two ratios. If we put AB over CD, AB over CD will be equal AE over AC. try to look carefully with these two ratios. Try to concentrate to find out what's similar, what's the same. You can notice that this ratio, the same is this one, but it's multiplied or reciprocal. So we can put this ratio as the following. We can put CD here instead of AB and the other, and vice versa. CD over AB here equals AC over AE. Yes, now we succeeded to find that AC here is the same as there. So we have two ratios are equal from the two triangles here. So we can easily prove that the ratio AC over AE equals AD over BE, which is this one, equal AB over CD. When you look at these two triangles, you will find that AC here in the first triangle over AE in the second one, which is this triangle, and we have this big one here. Yes, they are similar. Yes, so from the similarity we can easily prove that the measure of this angle equal the measure of this angle, and they are alternate. So CD here parallel to AB, and we can prove that this angle, which is DAC, equals this angle, and they are alternate, so we can prove that them easily that they are parallel also. Okay, my dear students, I know that these questions are very difficult for the others, but you are intelligent, so until we meet again next week, inshallah, be happy and study well. Thank you. Goodbye.